Arun Kumar also came. Okay, so just compulsory read the things, guys. Just compulsory read 1 or 2 times. So very small kind of stuff. Right? These
Good
are
morning.
yeah, good. No. These are the different networking devices are there. I'm giving some different type of different networking devices: hub, repeater, switches, bridges, routers, modems, different type of networking devices are there, which is I highlighted. That is actually we are going to discuss. Is actually software VPN, hardware VPN kind of stuff. IPS, IDS for security purpose. CSU, ESU, DCE, DDE. So like one side DTE, one side DCE, one side CSU, another side DSU. Like it will be there. Okay. IPS, IDS, both are institution detection system, institution prevention system. This is like a security purpose. Firewall is again security purpose. VPN is to connect a remote connectivity purpose. Okay, these are all a WAN connectivity purpose. These are all for a WAN connectivity purpose. But we are not discussing about this one directly. But we are going to discuss hub, switches, routers, and modem. The 4 things are important. Guys, this is not just like I'm giving single line to know what it is kind of stuff. Okay. So single kind of thing. It is what is the hub? Very simple. Just where we use a hub in LAN communication and small type of networks. Of course, I will explain each and everything. Just know 1 or 2 basic points. What is a repeater? Repeater is a device which repeats the signals. Okay, it will receive a signal and repeat the signal, so then we can communicate longer distance. Example, normally we are using in LAN communication UTP STP cables. You know, UTP STP cables support only 100 meters. So what is this repeater will do? Repeat the signal. You want to communicate more than 100 meters, then we need a repeater. Another example is Wi-Fi extending Wi-Fi is there now. That is also comes under the repeater. Switches again same LAN communication. Hub and switches both are for LAN communication. Switches but used for both small network and large networks also. Small size of LAN network, large size of network also useful. And switch know how to understand MAC address. It will understand a MAC address type. Bridges, software based bridging between 2 networks or 2 NICs kind of stuff. Okay, bridge is actually not a physical device, it is a software based bridge. Next one is a router. Router is works in both LAN and WAN communication. Actually, it is connect your LAN to WAN connectivity. Okay, so internetworking device. Router is a internetworking device. What is internetworking? Communication between 2 or more networks. So when you want to communicate between different networks, we need a router. It shows best path to reach the destination. So, okay, so that is the router. Modem, modulator and demodulator, which is used to connect your internet via ISP, Internet Service Provider. So you have to connect it to ISP, then only we will get internet using telephone cables, fiber optical cables. Okay, like you go to BSNL in certain areas, BSNL or maybe Airtel, they use the telephone wires to give internet. Okay, and nowadays most of the internet service provider are using optical fiber cable. So they'll connect from your modem to ISP to the
Sir, voice is breaking.
fiber cable. Line is need. Okay, voice follow means there is a first important thing is speed test. From my side, internet speed is good. Because I connected with the wire. Wi-Fi is signal weak, so I use a wired connectivity here. Okay. Okay, guys. Next one is we have to discuss about a hub. Because in this one, I have a lot of lines are there. I will going to remove certain lines and I will add up certain lines in the nodes. Okay. What is a hub? Hub is a non-intelligent device, which is used for LAN communication. It is a non-intelligent device. It does not understand MAC address or IP address. Okay. It broadcasts the packets to every device in the network. In what is it will broadcast to the packet to them. Okay, of course it is. We are using in a LAN communication. Okay, and suitable for a small networks. Okay, because of this broadcasting, and it is a layer one device. There is a OSA layers. As per OSA layer, it is a layer device. I'm going to add some more points. Okay, meanwhile I will take few things from here. This is how hub page look like, guys. It's a box and there is a RJ45 sockets. Simply have to connect with the wires. Hub is also called as a, this is not a very important, but still it is important. Single broadcast domain and single collision domain. So what is this collision domain, broadcast domain? And this is the another point it is I have written. Okay, it broadcasts packet to every device in the network. How it will broadcast? That is also. No? So I'm going to draw something. If you don't get it, I will draw in the paint brush also. Okay. So this is my hub. Okay. This is hub and having 8 ports, first port, second port, third, port number 4, port number 5, port number 6, like that. Okay, so 7th port number. Maximum port numbers generally for any hub is so 8 port number. 4 port number, 8 port numbers, hubs are there. Just I'm removing everything, just I put a 4, then the size will be reduced. Don't get message. Okay. And next one is we have a systems. Okay, we are all using star topology only. Okay, devices are connected to centralized device. Okay, all devices connected to centralized device. So this device is connected to first port number. This device is connected to second port number. This device is connected to third port number. This device is connected to fourth port number. Think like this. And I want to put a names for these devices, guys. This is PCA. Okay, so this is our hub. Okay, so what will happen while sending a packet? For example, you say like A to B communication. PCA is sending packet to PCB, a ping command, something like that. So what happened? And packet goes to port number 1. Okay, hub go to hub port number 1. Packet go to hubs port number 1. Okay, and hub don't know where is PCB. Where is PCB? So hub sends packet to every device, means to PCB, PCC, PCD also. Okay, this is what happen every time, not only one time, every time it happens. Every time means PCB to PCC. PCB send a packet to hub port number 4. PCB send a packet to hub port number 4. And hub don't know where is the PCC. So it will send to PCA, PCC, PCD. So this is what we call it as a broadcast. That's what we call it as broadcast. Guys, understand? So number of collisions high because of this broadcasting, and there is a packet data loss is also high. So it is that's why it is called a single broadcast domain and single collision domain. So what is the collision domain? Collisions are occurs at a total hub level. Okay, so then because of the collision, packets are collide each other and the packets are damaged. So the number of collisions are high. More compared to other. Okay, more. So packet data loss. Into this. Why. Font different. So packet data loss. So packet data loss means again it is error kind of stuff. Okay. So this is our hub and switch guys. So then also you can try like this. You can reduce the more occurrence space. That's why it is better for a LAN communication. Of course, it is for a LAN communication. And another words, guys, it is suitable for small networks. Why suitable small networks? It broadcasts packet to every device in the network. Okay. So then number of collisions are high. So packet data loss is there. So if you have a more number of devices, for example, instead of 4 or 5 or devices, you have a 10 computers are there, 100 computers are there, 200 computers are there. Think like this, every time packet will be damaged. Okay, it is kind of slow communication kind of stuff. Next one is repeater. What is a repeater? Repeater is it repeats the signal. So then you can send a signal. You can send a signal, or you can send a packet for a longer distance. Sometimes hub is also act like a repeater. And I will show you how repeater is look like, guys. Repeater. It is directly Wi-Fi repeater that came. No, it's just a normal network repeater. Is I need a like this. This is hub. This is the repeater. That's the difference. Okay. In our olden days, guys, we have a this is a somewhat repeater. Okay, so they will connect one wire here, another wire is going outside, like it repeat the signal. Same goes for hub also. Okay, actually you can cut the hub because already I given how hub is look like, but it is okay to that one. Next one is, guys, not only wired, wireless hubs also there. Wireless Wi-Fi extender is a Wi-Fi extender is an example for a Wi-Fi extender is an example for a repeater. Okay, so you are sitting in a longer distance. You are in sitting in a long distance. So you are unable to catch the signal. Your Wi-Fi router is in a one room, and you sit in another room. For example, I sat in a class of cabin, so the Wi-Fi router is somewhere located. Okay. So what we have to do? So we place this Wi-Fi repeater. We place the Wi-Fi repeater there to send a signal, like exactly what it is happen. It is like this. Okay, so we can draw the diagram also, or we can directly copy the diagram from there. Okay, just for understanding, guys, this is my Wi-Fi router. My Wi-Fi router. So this Wi-Fi router, actually we are connecting for our internet purpose, right? We have our Wi-Fi router. So you are in the range. If you sit in the, yeah, tell me. If you are sitting in the range, okay, you have a, for example, you have your own mobile or laptop, okay. So you are in the range, so you will catch up the signal. But you are located in a long distance, so then it is, we can't able to catch complete signal. Maybe it is 1 point or maybe no signal. It's because of you are out of range. This is in the range, this is out of range, for example. So what I do, I use a Wi-Fi extender between these two devices. I use a Wi-Fi extender between these two things. So I can catch the signal. Okay. So Wi-Fi extender will receive a signal from Wi-Fi router and repeat the signal. So then it will go to the long distance devices. Repeater or extender, what are the name you put it? It's already name become bigger. Yeah, this is understandable. Okay. So this is within the range, it is out of range. Now this is also will get a good signal. It will occupy a lot of space here. Just for our understanding only. Okay guys, do you understand what is a hub? Hub is a non-intelligent device. It does not understand MAC address or IP address. We use hub in a LAN communication, suitable for small networks. As per YSA, it is a layer 1 device. Hub broadcasts packets to every device in the network. Okay, so a device is sending a packet to another device, but the same packet is sent to all other connected devices. That is the hub. And what is the repeater? Repeat the signal. Okay, and this is a wired type of repeater, and this is a wireless repeater. What is the use of wireless repeater or a wireless extender? So if you are not getting a signal from your Wi-Fi router because your location is far from the Wi-Fi, you are not in the Wi-Fi router range. Okay. So what you do? So we put a Wi-Fi extender. So Wi-Fi extender receive a signal from your Wi-Fi router and repeat the signal, and it is our wireless device will be receive a full signal. It is in between these two devices. Let's understand that part. Nisha, Vitnakar, Ravi Ranjan, Saurabh Maurya, Shivani Pandey, Shreya Rathore, Chaudhary, Vaibhav Pratap Chand, Vivek Gupta. Okay, Vivek Gupta. Okay. The next one, guys, switches. Okay, switches will take a few more extra point compared to hub, guys. Switch is a intelligent device. It understand MAC address. Switch understand MAC address of connected device. It understand MAC address of a connected device, and it maintain a create MAC address table create a MAC address table by mapping MAC address of device to the connected port number. Okay. And it may maintain the MAC address table. Initially, broadcast gets to every device in network. Later, unique packets once it learn using MAC address table. Okay. Actually, we have to put some more things here, so then I will rearrange it. This is another point. This is removing associated. Guys, see, look at here. It is an intelligent device which understand MAC address of a connected devices understand MAC address. Which understand MAC address. The okay. Switch understand MAC address of connected devices. Switch use okay MAC address. It understand MAC address, not IP address, guys. Understand MAC address. Switch used for LAN communication, and it is a layer 2 device as per OSA layer, that is a data link layer, and used for large, small and large networks. We can use in a both small LAN networks and large LAN networks. We can do it. Okay, large number of devices can connect. Okay, it maintain a MAC address table. So what is this MAC address table? So switch create a MAC address table. Switch create a MAC address table by mapping the MAC address of the devices to the connected switch port number. Okay, so it maintains the MAC address. How this MAC address table is doing, like how it will create it, I will explain that one. Okay, so switch initially broadcast packets to every device in the network, later unicast packets using MAC address table. And of course it works with floating and cut through switches, so different type of storage things are there, which reduce the number of collisions compared to this less packet data less. Switch is also called as a single, this is also single broadcast domain and multi collision domain. So collisions will occur at port level. Completely font is different also. So lettering is also confusing. Yeah, this is somewhat good. Look like same. Okay, guys. Again, switch is a intelligent device. It understands MAC address of connected devices. It is a layer 2 used in LAN communication, both large and small networks. Large number of devices we can able to connect. Number of devices we can connect. Okay, so it will maintain the MAC address table. What is MAC address table? It is a map of MAC address of devices and the switch port number. Okay, switch is actually initially it is a broadcast packets to every device in the network. Later, unicast packets using MAC address table. Okay, so to few more points I want to add this thing. Mainly two functions of switch is there. What is a MAC address learning and forwarding? Guys, switch is a layer 2 device. Remember, switch is a layer 2 device. So if anybody asks, what is layer 3 device? What is layer 3 device? So what is layer 3 switch? So switch is a layer 2 as per OSA layers, layer 2, but it is showing layer 3. Of course, there is a layer 3 switch is there. The layer 3 switches function as a switch as well as a router, because a router is layer 3. So this is type of switches. Layer 3 switches we use it for a inter-LAN routing, VTP. Okay, like that kind of communication. Just I'm giving point, guys. If you don't get it, no problem. But it is there. Okay, this is how switches look like, guys. If you see, it's a large number of ports are there, not a 8 port or 4 port. Of course, small port number switches also available, but you can see there is a large number of switches are there. Okay, so this is how switches look like, and then this is the diagram. So I will try again to put this diagram here. Yeah, tell me. Yeah, tell me, guys. So what is anybody want to? Okay. Okay. So this time it is a search. Okay. There is a common question again. What is the difference between switch and hub, guys? So I have a number of ports. Example, I have taken a 8 port switch. Okay, only 8 port switch. Okay, just for example, but I'm not connecting all 8 devices here, of course. Same thing like a star topology. So currently only 4 devices enough because we don't want a very big diagram. Okay. If you don't get it, I will draw in a paintbrush. I connecting to these ports, which is more easy to connect. That's what I am trying to connect. Okay, 1458. Okay, corner devices only are connected. That is what is it? So this is a PC, A PC. A PC. PC. PCB. So as I said, guys, every device need to connect. Okay, every device those want to connect in the network, they need a NIC, network interface card, and you have a NIC means. So NIC, every NIC having a MAC address, every NIC having a dedicated MAC address. So if we have a MAC address here, so for example, I'm giving just for our understanding this MAC address. Originally MAC address is a 12 hexadecimal number. Just for our understanding, I'm giving the MAC address like this, just for our understanding. Okay. So there is a lot of explanations are there, but I'm trying to cut down a lot of things. Again, I'm telling every NIC having a MAC address. So with NIC, we can able to connect it to the network. Okay, this is what I'm trying to say. Every device having MAC address. Of course, they should have an IP address also. I'm not writing an IP address here. Okay, so this is a switch. So what will happen when we are trying to communicate in the network? Okay, the first thing is A want to send a B. PCA sending packets to PCB. So what it will do? So and to switch port number 1. Okay. A send a packet. A from PCA packet sent to the switch port number 1. Okay. Now which don't know it is PCB. Okay. So it send packet to every device. But meanwhile, guys, switch learn MAC address of PCA, because when you are sending, you will send your IP address and MAC address, destination IP address, destination MAC address. While you are sending, like you write a letter, you write to address, from address. To is a destination address, from is a source address. So automatically switch understands what is the source address. In that one, source MAC address. What is source MAC address? One. So switch map switch maps A1 to port number like that. Then MAC address of devices maps to the respective port numbers. Numbers. So that is called MAC address. I'm writing complete history. Okay. I have to write down that MAC address table also, but I've written a big story of it. Okay, so I'm removing this part, guys, because it's become a very big line. So I've written lines in separately. So here it is. The first one is PCA sending to PCB. So what happened? MAC address table will create parallelly. So first one is MAC address and switch port numbers. This is a MAC address. A1 is connected to 1. Like that. When these devices are communicating each other, like a B2C communication, B2C1 communication, then it learns B1 is connected to port number 4. Okay, and then C1 is communicated to A1, for example. Then it lands C1 is connected to 5. Okay, same way D1 is communicated to one of the device, and again it will communicate it, send a packets to, so it is map port number is 8. Now MAC address table is created. MAC address table is created. Okay. Now think like this. D1 want to send packets to A1. Sorry. PCD. It's the PCD want to send a packet to PCA. What is A's MAC address? A1. So where is A1? Port number 1. So directly it will send a packet to port number 1. Simply can say, okay, D1 is connected, D is connected to port number 8, and the packet is sent to port number 1 directly. Okay. So D is connected port number 8, and A's MAC address is A1. Okay. Packet send to port number 1 because of because of as per no, I don't write anything. This is enough. Just we should understand, not like a entire notes. The notes is notes only. Okay. So the use of MAC address table we should understand, not just what we write and all. Okay.
ఎలా ఉన్నా అర్థం పడింది చెప్పదు
Okay. So guys, PCA send a packet to PCB, and I'm trying to send a packet so that PCA send a packet to switch port number 1. Okay, switch don't know where is PCB, so it is don't know where is a B1. Okay, B1 MAC address mapped initially, so it send a packets to every device in the network. And the next point, what is switch learn the MAC address of PCA? What is that one? A1. So switch maps A1 to the port number 1. Okay, so where it is connected to port number 1. Okay, so that is what it is, a MAC address table, so that switch learn MAC address of the devices. Okay, so and maps to the respect to port numbers. This is called a MAC address table. Okay, next I'm giving another example of what is the use of MAC address example, MAC address table example. Look at here. If ECD send a packet to PCA, for example, packet A. So PCD, which is connected at port number 8, right? So send a packet to port number 8, and PCA MAC address is A1 MAC address, which is I stop writing, right? That is what I'm writing here. Now packet from PCD, packet send to port number 8. Port number 8. Okay. Then what is the destination MAC address? CA's MAC address it is. What it is? That is A1. A1 is at port number 1. A1 is at port number 1. Okay. A1 is located at port number 1. Okay. So packet send to switch port number 1. Okay guys, this is the how MAC address table is done. So it is initially broadcast the packets. Initially it is a broadcast the packets, but later it is unicast the packet using a MAC address table. Switch understand MAC address of a devices. This part is not required function of switches and all because already it is written here. Okay. This one is important guys. Again, switch is a intelligent device. It understands MAC address of a devices. It used in LAN communication. As per YSA layer, it is a layer 2 device data link layer. Small and large networks, it works in a small and large networks. Large number of devices can able to connect to the switch. Okay, switch maintains a MAC address table which is created by switch only. Okay, so how it is? It is a mapping of MAC address of a devices which is connected to the respective port number. You have to read it and you have to frame it again guys. If any more point or my way of writing is different, so then do it. So don't go blindly, also just read it, and when you try then you will get a proper sentence. You should not change the meaning, that's it. Okay, if you understand, you don't change the meaning. So without changing the meaning, you can put your any sentence. Okay, switch initially broadcast the packets to every device in the network. Later unicast packets using a MAC address. What is that one? If you are sending a packet from a device, so the packet sent to the destination by broadcasting only initially, but switch will learn your device MAC address while you are sending and receiving a packet. So switch understand what is your device MAC address and map to its port number. Like that, it will create a MAC address table. So using MAC address table, next time it is very easy to communicate using a, okay, it's do unicasting. Because of this unicasting guys, number of collisions will be reduced. And have written a single broadcast domain and multi-collision domain. What is multi-collision domain? At port collisions may occur, not entire switch. The collisions will occur at a same port. What is this collision means? a device is receiving a packet same time from the multiple devices. Okay. All are connected, but all are sending to the same port number. All are sending to same port. So what happened? At port, the collisions may occur, but it is reduce the number of packet data loss. So that is also suitable for a large networks. But there is a floating and unicast concept. I just MAC address table is a unicast concept. Floating is a different other concept. Is there different type of switches? Cut through switch and store and forward switches, maintenance switches, non-maintenance switches. Okay, so this is a different part. This is a completely manageable switches, non-manageable switches. This is different part. Okay, L3 switches works as a switch as well as a router. Guys, are you up to now? Okay, I told about hub and switch.
Yes, sir.
Okay, this is the bridges, guys. I'm not going with the bridges. I'm going with the router and modem. Okay, so we'll complete this part and we'll take a break. What is a router? Router is a also intelligent device. It understands IP address, logical addressing. What is logical addressing? One of the logical addressing is IP address. Okay, you can see it is intelligent device. It works with a logical addressing. Switch works with a MAC address. Router understand IP address. Internetworking device. It means it communicates. It connects to our more networks. Of course, it will communicate between. It make a communication between two or more networks. Okay. Internetworking device. It is a communicate. It make a communication between two or more networks. We use for LAN and WAN communication, and as well as it is a layer 3 device. Okay, so this is how router is look like. Okay, in the back side of the router. So router symbol is different, guys. I'm not going with symbol, just so last time I written for a symbol is small symbol. It is written. Okay, this is one network and another network, so both are communicating each other. Bani. Okay, so here are the point is what is router? I said router, but it is actually router. Root. What is root? Path. Okay, what is root? Path. Okay, so and also starting of networking, I showed one diagram that is also I will go back once. Networking, internetworking diagram. Just will go back. So it is. This is a network. This is a network. This network connected to this router. This network is connected to this router. Okay. So it means it connects two or more networks together, internetworking device. And it shows the best path to reach the destination. Okay, what is route? Route means path. Router shows best path to reach the destination. This router using routing tables to know how to reach the destination. To know that how to reach destination.
అప్పుడు జరిగి పెట్టేయండి నేను తీసుకుంటా
అలాగే. Okay. Router using routing tables to get to know how to reach the destination. Both sentences are same, guys. Just everything. Okay. What is this routing table? Routing tables in your router. It is can be created manually or it can be created automatically. If you create a routing table manually, that is called a static routing. If you create a routing tables automatically routing tables are created using a routing protocols called a dynamic routing. These routing protocols are a dynamic routing protocols are two types, RIP and IGP and EGP type protocols are there, guys. RIP, AGRP, OSPF, BGP, ISIS. These are all routing protocols. Okay. Routing information protocol, enhanced interior gate, where routing protocol opens shortest path first. You know how this routing protocols works depends upon the depends upon the traffic, depends upon the link status, bandwidths, okay, delays. It will calculate the path and it will tell you path how to reach the destination. Okay, this is about your basic point of router, and there is a modem part is also there. Yeah. Again, guys, what is a router? Router is an intelligent device. It works with a logical addressing, means IP address. It is a internetworking device. It makes a communication between two or more networks. It works in both LAN, like this is a LAN connectivity. This is another LAN. So and both LAN and WAN communication it will use. Okay, and it is a layer 3 device. Router, it shows the best path to reach the destination. Okay, router maintain the routing tables. Either it can be created statically or dynamically, means automatically. Okay, so there is static routing and dynamic routing kind of concept is there. I want to tell something now. There is a command. Okay, guys, check it. Ping is a command, and there is a trace RT command. Okay, ping is a command. There is a abbreviation for a ping command is there. I'm not going to tell that one. You can search what is a ping abbreviation. Another one is trace route or a trace RT. Okay. Let's look at here. This is a command prompt. I'm going to ping www.google.com. Okay. www.google.com. So I got a reply from google.com IP address. See this? This is the google.com IP address. Okay. I got a reply from google.com. Means ping is successful. Ping is successful. So ping command will tell, can you reach destination? What is the command? What is the ping command? It's a test command. It's a test command to test connectivity between two devices or two nodes like this. From source to destination. So we said device, but you can say like a from source to destination. So we can test connectivity between from source to destination or from between two devices. Okay, anything you can use the word. Okay, this is the thing, guys. Remember, ping use ICMP protocol, at Okay, and the request, the packet is echo request. Echo request and echo request and receive echo response. This is how it works. Okay. This is an example how ping command is showing. We have very less space, but I tried it. I will go down. Okay, one of the important command is ping command. Okay, so enter data I given, not a small one. Okay. Okay, guys, this is the ping, and this is how ping works. What is the use of ping? Understand ping?
Yes, sir.
Yes, sir.
We can do troubleshooting
Yes,
with the ping command also.
Yes, sir.
But this is actually I want to tell about a router and Tracert. But one of the network command already I told one is a get MAC for checking a MAC address of the NICs.
Hello?
IP config all. Tell
Hello?
me. Hello? Tell me.
Can you scroll down this page? Yeah.
Okay. Already we discussed get MAC, IP address, sorry, IP config and IP config space slash all. Okay.
Yeah.
The
In the
next
screen,
command is ping command. You tell me.
what is ICMP protocol and echo request?
Yeah, you know echo, normal English echo.
Yeah.
Right. So this is my device. So this is for testing purpose. It means the data is simply to understand, right? So I send a packet.
Yeah.
To the destination. And the packet, like this is AB. I send a packet. Inside a packet, it contains echo request packet. It is. I send echo request. It understand it is a ping command, so it will replace same data. So then we can understand, we can able to reach the destination and we can able to reach the destination. So we send a packet to destination. Destination is from destination we received means source to destination. It is clear, so no problem inside. When you get a reply from destination, so that's the echo means what are the packet you send, you'll receive same packet only. This is only for testing. Next one is ICMP. First of all, is a protocol. Protocol means understanding the communication protocols. What is the type of communication? The protocols define what type of communication it is. You open a web page. You open a web page. For example, w3schools.com. I open. This is the example I'll tell. See, HTTPS means your request is I want a web page. I want a web page. Okay. For example, you want to upload and download a file. You may use a FTP.
Yeah.
You want to send a mail, receive a mail, SMTP, POP3 IMAP, like different type of protocols we use in a communication. So protocol define what type of communication. Same thing, ICMP protocol will tell you it is a ping type of communication. So we are doing ping testing. So then it is a ICMP protocol. The function of ICMP protocol while you are sending, it will tell to the BPC protocol is ICMP. Yes, it is understand ICMP protocol. It is a ping kind of communication. So it receive a packet and it will send the packet to the APC. So BPC understand what is your request, what is your communication. Okay. Understand, guys? Good, good. That's a good thing. Okay. You ask a question means that is I can understand your understanding. Okay. Next one is a trace. Know whether you can able to reach destination or not. So trace RT will tells you how you reach the destination. Okay. Just only one part only tell how you reach the destination. Same google.com. I'm doing trace RT. Pinging. So my packet reach up to google.com server and I got a reply from google.com. That is a ping command. So I know I can able to reach the google.com server. But now I want to know how I reach the google.com server. Okay. It's a trace RT or trace route. Okay, first the packet is going to my default gateway, my router to my ISP to some other router. Finally, I will reach the destination. Guys, in the entire world, it is with a lot of routers, and between the routers, there is a connectivity. Okay, the routers will tell you how to reach the destination.
Voice is breaking.
They're not broken. So voice breaking. Sometimes you go by via journeys are there. No? You have to stop at one place, like you have to go one place, then there, from there, like that. Okay, so the Tracert is okay now. Okay, if everything is in one place, good, right? It is telling guys, first you reach from your PC to your default gateway. Okay. Okay, so this is next I reach my ISP broadband connections. So like that, I finally I went to some other router. Finally reach the destination. This is will tell you how you reach the destination. So that is a trace RT command. Okay. So you can try guys, trace RT www.facebook.com. Don't put facebook.com guys. Okay, browser is an intelligent one. It will understand you put a facebook.com, youtube.com, then automatically the headers will fill. Okay, this one we don't understand. Okay, You put a youtube.com, you don't understand www.youtube.com. Gmail.com means mail.google.com or www.gmail.com. Like that only. You have to do both ping and as well as a Tracert. You can practice like that. Okay. So the very small one and the last one is a modem. Modem is a modulator and a demodulator. That is a modem. Modem is a modulator and demodulator. So in a last one class already I given about your Wi-Fi router details, but here it is modulator and demodulator. Okay. So what is a modulator, guys? It modulate your main frequency and it will forward and then and at end it will demodulate and receive. In our LAN communication, guys, all communication, it is a digital type of signals only. We are electrical signals, but it is digital form of signals. But you want to send like from your home or from your office to the ISP, okay? You have to send to the ISP, ISP to further it has to send. So our signal don't have strength because our communication is within 100 meters communication. But your ISP is a very long distance. So how it will be sent? It will convert into analog form. Analog form. Okay. Because whatever your LAN is there, okay, so it has to be sent outside through telephone cables, right? You have to send through telephone cables or maybe fiber optical cables. Now internet is there. Modem makes you to connect it to ISP. So in modem, when you configure your username and password, so this username and password will send to ISP. First of all, there is a connectivity, no? So through the connection, first it will go to ISP. ISP, it will verify your username and password. Once it is authenticated, ISP okay to give a internet connectivity to you. So the internet connectivity comes up to modem. From modem, it is distributed to your system. Okay. If you have multiple systems and you have your own LAN network, then we use a router and switches and wireless access point. Okay. Some Wi-Fi routers are routers having a built-in modem. That's why you don't see direct modem part. Okay. So this is, for example, you can see, guys, this is a green one. Will tell you this is a WAN connectivity, and this is a LAN connectivity. This is for a wireless connectivity. Okay. Some are with the telephone wire, D-Link array. You can see that is a kind of connectivity. Like this modem to your system. Okay, before modem, digital signal convert into analog signal. It passes through telephone wires. Not this one exactly. This is exactly. So this is a modem, guys. So it is connecting to our router. He is trying to distribute with the two routers, but this is the modem and this is a router. Like not even this one. This is a different setup. So it is not this one. See, this is the fiber optical modem. This is a good picture. Somewhat.
Yes.
Okay. So you get a cable. This is a separate modem, and you can see there is a connectivity go to your router. So the router will distribute things for separation purpose. Some routers built-in will get it directly, will get a within the point only.
Hello, sir.
Tell me.
Yes, sir. I'm telling, sir, how can we differentiate between like a modem and Wi-Fi and switches to see a pictures? These are like a same.
So you do one thing very simple to know. First of all, the best always to learn any tech thing, not a tech blogger, guys. Your e-commerce websites. Okay.
Yeah.
So you can try from here any networking components, routers, switches, see networking devices. Normally, home purpose usage, you will understand from it. What is the router part? What is a Wi-Fi extender? It is how it is. Sometimes router modem look like same. Sometimes little different. Okay.
Yeah.
So like these are the different routers. Why 2 are there? Why 3 are there? Why 4 are there? And see the details. What is this 300 Mbps? What is N3 router? What is AC model? Okay, what is this AC model? What you are getting from AC model? If you open, you will get it. And see, this is our Airtel and Geo data 4G hotspot connectors. So what is that one? How to connect? Even they will give some diagram for that one. This is some extender it is. Later you can go with a Cisco website or a ComSci N plus kind of stuff, and better walk into one network related shops. Okay.
Yes.
So you will get to know what are the different things. You can see. Okay, so this is one, and I have one picture in my screen, so I am searching. That is a Nokia picture. Yeah, this is the one. This is a Nokia fiber optical modem, guys. So you don't need any of what we can say a separate Wi-Fi router like this. So it is directly a fiber optical cable is connected here. Okay, fiber optical cable from ISP, and this is the Wi-Fi router, and we can connect through the LAN communication as well as a Wi-Fi also. This telephone wire, the telephone wire is go to the telephone, normal telephone only. It is not other telephone, normal telephone. Okay. So currently, most of our homes having modems are comes with both modem, router, and switch kind of stuff. This is for a default gateway, and here I put a one diagram. So that is a small office, home office kind of diagram it is. Okay. So already I given this picture to you earlier. So if you want, I can add it, but taking a lot of time. So I will take one picture. Already in the starting day only in the network, I think already I given. Otherwise, you can take it from here. Okay. See guys, the modem is trying to connect ISP. It's a last device. Okay. Once the modem receive internet, it will give it to the router because we have multiple devices. So this public net internet should be distributed like this. Actually not like that. these multiple devices, these devices are connected. These devices are connected like this. Okay, so these devices are connected either wired or devices. Wireless devices will connect it to wireless access point. Wired devices will connect it to switches. But these devices want to communicate each other. We don't need any router or a internet kind of concept. But if these devices want to communicate outside of the network, okay, they need to go through this router and the modem to ASP. Finally, we reach the destination. On the other hand, this is one network, right? In outside different network, this is different network. We need a device to make a communication between this network to this network. So that's why we are using the router. Some routers are having a built-in modems, switches, routers, and all. And already I given that list. Whenever you are communicating outside of your network, so you have to go through the default gateway. So your router is act like a default gateway. Okay, so this is about your modem and your router, your switches, and already given guys wireless access point. You connect the devices through wireless access point, that is a WLAN. So please refer starting when I start with a networking kind of concepts. I think for your batch I told, if I miss something, yeah, so it is already given this diagram. Wireless LAN, this is LAN, this is your private network, but when you communicate outside means that is a different network. We need a router to communicate in the internet. So we need a connectivity to internet, that is we need a modem. And already written here, your Wi-Fi router, generally in a home Wi-Fi router act like these devices are a modem, router, wireless access point and switches. And also it is act like a DHCP server and DNS server and a default gateway also. This is what I'm trying to say. Compulsory read at least once guys, so then you will get some point from it. So next topic is wireless layer. So before that one, what to do? Take a break. Okay. I have taken almost like 1 hour, more than 1 hour, so no problem. So take a 10 minutes of break. So 12:35 is okay. 12:40. So we'll take up to another 40 minutes. At least 2 hours of voice layer I will give you. Another 30-40 minutes I will take. 30 minutes. So come back fast. 12:30 for 10 minutes is free.
Okay.
So relax and be back.